Right, hello everybody, and welcome to the second ever .NET Roundabout. My name's Nick from TRG. We're the guys who put on this event, but we also put on the Agile Roundabout, the JS Roundabout. Thanks very much for Eugene and Adrian for speaking today. First, we got Eugene, who's Lead Data Quality Engineer at ASOS. Giving us a talk about the quality and assurance framework, and then Aidan from Amido, giving us a security talk on how .NET devs should respond to hacks like SolarWinds and stuff like that, which is me and Aidan were chatting earlier, is back in the news at the moment. I think Biden's just sanctioning Russia for these sort of SolarWinds attacks. So yeah, really looking forward to that. I think we'll just wait a couple of minutes just to let maybe the last few people log on, and then we'll get going. Probably worth just saying as well, during the throughout the talks, just any questions you have, just put them in the comment section. I'll be monitoring them throughout, and then at the end of both the talks, we'll bring everybody back, and I'll go through some of the questions. Okay, yeah, we'll just wait a couple of minutes. I'm just waiting for the thumbs up. Here we go. Okay, cool. Right, ready to go. So Eugene from ASOS is first up. After you, Eugene.
All right. Thank you very much. So, good evening. My name is Eugene Niemand. I'm lead QA engineer for data services at ASOS. If you want to know more about what we're doing, feel free to look at our tech blog. If you want to work for us, we've got an ASOS career page. And if you want to get in contact with me, that's my LinkedIn address. I'll put these up at the end of the show again. Okay, so I want to give you a quick overview of our challenge we had that we had to solve. So I'm going to start off with the scale of what we're doing at the moment. So to give you an idea of last year's Black Friday stats for the peak day, just the Friday, we had 24 million visits, about 1.2 million orders, and 90 million pounds of revenue. Another stat is our first time orders per second. So for the peak hour that we had, Android was 0.3 orders a second, iOS 1 order a second, and then web was a whopping 5.8 seconds. So all of this has created a problem for us because our planning and trading is very UK centric in a single currency with little visibility of stock positions or margins. We've limited access to online analytics and to help with decision making. And then the systems we have aren't scalable and able to support the processes, and it's very labor intensive. We just released our half-year results, and our profits this year is already up 275%. So we had to do something to manage the scale. Now, we've been replatforming all our backend systems for the last 4 years, and this has produced a new challenge because of the reasons I've mentioned. So what has this changed? So our business definitions have changed. So our retail teams will now be able to plan and trade by our fulfillment centers in multiple currencies and have access to global trading insights to shape their plans. And then teams will be able to price relevantly for each web store to deliver competitively priced products to our global customers. So we're moving from a very UK-centric market to a global market. This also means that our metric calculations and sources have changed. We've got new and consistent hierarchies that will provide visibility of our products across all global markets, and will also allow the teams to forecast and validate sales and stock levels. So this means we need to verify our metrics across different systems and different sources. And just in data services, where our platform is responsible, we have around 1,200 impacted or new metrics. So I'm going to give you a quick overview of our environment, and then we'll get into how we do this. So firstly, we have blob storage. We use Azure Data Lake Store for that, and this is for batch jobs like flat files, hierarchical files. We've got JSON files from microservices. We've got Parquet files from transform data from Databricks and Data Factory, and then other systems also place some files there for us to use for reconciliation. Right, the next thing we've got our analytical data store, or ADS. This is Azure Synapse servers, a SQL database, a SQL data warehouse, if you're familiar with that. This is the ingestion point for all our ETLs. So most of our data comes into the ADS from blob storage, and then is transformed from the raw flat files into well-defined data sets. The next up, we've got our enterprise data warehouse, and this is SQL Server 2019. We primarily use ADS as a data source, and then we further transform the data into a dimensionally modeled data warehouse. And then the majority of the data is retail and finance focused. Next, we've got the analytical workbench. So this is again SQL 2019. It uses ADS and EDW and other third-party sources as data, or third-party data sets as sources. And it further transforms the data into data sets used for insights and analytics, and additional enrichments, for example, browsing behavior, customer demographics, product views availability, market shares, and customer preferences. And this is used for, this is more customer focused rather than retail and finance. Then we use MicroStrategy as our main retail reporting tool, and we also use PowerBI as our main insights and analytics reporting tool. Now, we have all these purple arrows that's flashing. These are all reconciliation points or places where we copy data, transform data, and what we need to do is verify that the data still stays correct all the way from one end to the other end. So we've created a framework called Quality and Reassurance Reconciliation Framework, or QARF. It follows a very simple pattern. So for almost all of our tests, what we do is we query the source target and the source system and the target system to return a single metric for the previous day for one or more dimensions. We will then go row by row, column by column, and compare the data, or alternatively, we will use multiple columns as a composite key and then compare the metric. And then lastly, we will attach the results to the test in Azure DevOps, and we store more granular test information in Azure Table Storage, which I'll show in a second. Okay, so our tech stack, we've used .NET Core and C#. We use NUnit and Poly.NET. If you don't know what Poly is, it's an open source framework to have retry policies or short circuit policies. So when we use, for example, MicroStrategy APIs, sometimes these services may have performance problems, timeouts, so we just want to retry those a few times. We then use Azure DevOps to do our execution for us in our pipelines, store our data in Azure Table Storage, and then we report over everything in Power BI. Okay, so I'm going to give you a quick example, and then I'll set the scene of what we're doing. So firstly, we do black box testing. So we are not testing the code itself or the execution of the code. We are testing the output of that code. So as I said earlier, we may have 2 or 3 ETLs or MicroStrategy metrics or Power BI measures involved from the source to the target. So what we're doing is we're testing from source to target regardless of what happens in the middle. We do this in all environments, and then I'm going to set a scene now. So just to give you a simple example, so we want to verify the orders for yesterday by warehouse. And then this is data that we've received from our source systems, and then it goes through multiple ETLs to MicroStrategy. So firstly, what we're going to have a look at is how to create one of our test classes and how to set up a test case, how to query the raw ADS data, and then how we execute the MicroStrategy report, and then compare the results. So our class is very simple. You just inherit from this test-based class. We've got a business area called sales in this case, and then a metric test report builder, which I'll come into a bit later. And then we'll set up our test case. So you'll notice that we've got a order reference count parameter there. That is the file name in our queries project, which I'll show you on the next slide. Then next up, we've got the path of where the MicroStrategy report is and the report name. So here we do a database to report comparison, and we pass in a context for all of our different comparators we've got. So in this case, we're comparing ADS to MicroStrategy, and then we've got some optional parameters, and then just the test case parameters at the top there. So this is our queries project. So as I said earlier, we had a source system ADS, then we've got our business area, which is sales, and then order reference count is the file that we saw in the previous slide. And then we've got these tokens we replace for, say, -1 for yesterday, or -2 if we need to go back further, or any date for that matter. So in this case, what we're doing is we are querying from the source data the distinct customer orders by the build warehouse for the build date for yesterday. So when we execute that, we get something that looks like this. So on the 12th, we had 145,000 for FCO1 and then a few for the other two. So when we execute the report on MicroStrategy, you will see that the results are very similar, or actually exactly the same in this case. And there at the top is also the same path as what we saw in the configuration. Okay, so next we'll have a quick look at the framework under the hood and how this works. So firstly, we have readers. So we have a database reader, and in this case, we have standard token substitution for offset days and offset weeks. We then check if this is a service principal or integrated security, and we set up a connection string. We create a data table and log the data table from, create the data table there. And then lastly, we sort the data if needed, and then we log the data table to the console and return the data table. We then do the same or very similar sort of pattern for MicroStrategy. So we firstly get the report, an instance of the report. We then supply the prompts or the parameters for that specific report, in this case, like the date for yesterday. We will then retrieve the report data and convert it to a data table, sort it again if needed, and then lastly, we'll log the data table to the console and then return the data table. So in order to run queries against ADS or our SQL databases, and to get the queries from our query project, we have a query file reader. So firstly, we'll determine the extension of that file. So if it's not a PowerBI or batch file, then the extension will be SQL. We then create a resource name, and then we use standard .NET functionality to read that resource and return the text. So next we've got some writers. So we've got Serilog writer. So this is what we use to log to the console. So firstly, we write fixed width data columns, and we do it column by column for every row. And then when we've reached the limit, or when the data is finished, we will then just stop that. Okay, next up we've got the Azure Table Storage Writer. So as I said, we store some additional information in Azure Table Storage. So firstly, we will create, using generics, we will convert the data rows to a specific type of result, so with different schemas. Next, we will then check if the, lost my train of thought. So we'll create a default entity, and then over there we'll add some additional parameters if we need to. And then lastly, we'll insert that data into table storage. And then we've got some builders. So we've got a data reader builder. So in this case, we return an instance of a DB reader for ADS, and we supply all the necessary parameters. And then we also return a MicroStrategy reader, so we can read MicroStrategy. And then this one is the metric test report builder, which I referenced earlier. So we've got a specific schema in this case. So we've got standard fields that we want to populate. If the actual or the expected results are null, we just log that to a message. Then we check if the columns are even. If they're not even, we'll log that. And if there's any message up to this point, we'll just return null, and we'll stop the process at that point. If there's no messages, then we move on, and we will combine the test results with the above schema, or if it is empty, we will just combine it with an empty table. And also, if there's uneven rows, we'll just raise a warning that there's a row mismatch. And lastly, we create a diff report and log that to the console. Okay, we've got a few helpers. The main one that we use is our comparator. So in this case, what we do, we will assert that rows are equal. So for every row, we will check whether the columns match between the expected and the actual results. And for every column, we will do a data type specific test. So if it's a date, we do date comparisons. Numbers, we actually do some things behind the scenes where we do rounding in some cases, etc. So any column that fails gets logged where the assertion fails. So we don't fail the test immediately. So it could be that 2 out of 4 rows have failed. So we will log both the 2 rows that failed. Right, so lastly, this brings us onto our reporting. So we do reporting in Azure DevOps as well as in PowerBI. So the first one in Azure DevOps, this gives us a very good overview of all our different reconciliation pipelines, but it's at a pipeline level. So it gives us the last 14 days, and then it gives us the standard stats from end user. So did the test pass or fail? So it's not very informative. Next, we can look at a specific pipeline execution. So in this case, we had 282 metrics we tested in this specific pipeline. We had 6 that failed, and 1 of those was new. And then for every test we execute, we add some attachments to the test. So we will log the source data, so the data that came from the source system. We will log the source query that was used. So if we need to debug, we can see what query was used. We will log the target data and the target query. And then lastly, we log the target report, which looks like this. So in this case, we had the 3 warehouses we tested, as we saw earlier in the screenshots. And here you can see each warehouse, the source value, the target value, and the difference. Now, this is great for debugging purposes, but for management reporting or tracking progress, they don't want to go look at different pipelines and go look at different tests, etc. So, and this also sometimes hides information, as I'll highlight in a second. So what we do is we use Power BI for our wider reporting. So we've got a Power BI dashboard that shows us our last 5 executions. So you can see we're sort of 97, 99% at the moment. Now, when we look at the 11th of April, you see there's 5 failures. So what we would do on a daily basis is we'll drill down into that. So when we drill down in this example, you'll see there's 1 failure for ADS. So we will go look at that and we go to the details of this 1 failure. Now, when you look at this, you will notice that the failure is over there. And if you look at the source and target value, you will notice that they're actually the same. So you may ask yourself, well, why is this test failed if the values match? Now, if you look to the left of the failed message, you can see it's got 40 attributes. So this is a dimension. And what it means is that at an aggregate level, the test has passed, or it looks like it's passed, but we tested a lower grain. And this is the information that gets hidden with standard N unit results. And this is why we store additional information in table storage. So when we drill down into that specific one, we drill down into the attributes, you will notice that we've got that 3,700 amount there and the 47 amount there that was swapped around between 2 different business models. So at an aggregate level, they were correct, but they were allocated to the incorrect business models. So we use this to highlight problems that are lower grain. So hopefully you've got a better understanding and idea of how we do our reconciliation. I hope that was useful. Thank you very much for your time. And there's all the details again, as I mentioned earlier. Cheers.
Thanks very much, Eugene. We're just going to now move over to Aidan for the security talk.
Great, thank you. I hope you can all hear me. My name is Aidan Twomey. I am a consultant at Amido, a .NET consultant, and I have entitled my talk about security, I'm not afraid, you will be, and that's because for those of you who weren't at the first .NET Roundabout, Nick Crabtree of ASOS gave a very entertaining talk about the Hollywood School of Programming, where he gained lessons from films. I'm sure some of you have got the reference to The Empire Strikes Back, where Luke is starting his training. I don't know if this will work. Very good. So, young Padawans, how should we think about the expected damage that a security incident could cause the companies we work for? And so, very roughly, I would like to think of the two factors that contribute to the expected damage a security incident could cost, and that's the probability of an attack, how likely it is, and the cost of the attack. So, I wouldn't be particularly worried about an attack that had a low probability and wasn't going to cause much damage. But for, say, the most common security vulnerabilities, we should definitely, as developers, worry about those. And luckily for us, they are already classified and brought to our attention by the OWASP top 10. And the top vulnerability is always SQL injection and other kinds of injection. The second is incorrectly configured authentication, and all the way down the top 10. As developers, we should definitely be very familiar with those, and we shouldn't leave it to the pen testers or the security operations. They should be our concern, but they're quite well understood. So point you towards those for the common attacks. I want to concentrate on the rare but very, very damaging attacks. So the ones that really, frankly, scare the crap out of me. So we're going to talk a little bit about the SOLARWINDS exploit, which was discovered at the end of last year, in December 2020. The Vastaamo data attack was discovered around the same time. And then I want to spend a few minutes asking what should we as application developers, what should we do to defend our systems? So just going to dive into SolarWinds and what it is. SolarWinds is an American software company that produces networking software, so visibility on networks and all kinds of large network software. And it turns out they're an enormous company and a real attack vector. They've a lot of attacks. I don't want to dunk on them, but they've been really attacked. And it turns out that they have a lot of networks that they run on. So this is a list of their customers taken from their website. And it turns out that 425 of the Fortune 500 companies in America, top 10 US telecommunication companies, all 5 branches of the military, the Pentagon, the State Department, NASA, the National Security Agency, and the Office of the President of the United States. So a big deal. And you'll notice that this screen capture was taken from December the 13th. I believe they took it down a few days later because by December the 16th, the New York Times was reporting, it's now clear that the broad Russian espionage attack on the United States government and private companies underway since spring and detected by the private sector only a few weeks ago ranks among the greatest intelligence failures of modern times. So yeah, as Nick pointed out earlier, President Biden very helpfully bigged up my talk today by expelling some Russian diplomats. And it did occur to me that some of you following the news will know that the Russian army is assembling and performing exercises on the Ukrainian border, and the US Navy is sending a couple of ships to the Black Sea to patrol. When you bear in mind that the Russians have been reading the US Navy's emails for most of the last year, you might agree with Senator Dick Blumenthal, who said, "Today's classified briefing on Russia's cyber attack left me deeply alarmed, in fact, downright scared. Americans deserve to know what's going on, declassify what's known and unknown." Well, it's fair to say that the American authorities, the CIA and the cyber authorities, haven't completely declassified and haven't necessarily been entirely open. I'm sure there's a lot they don't even know yet, given the scale of the attack. But Microsoft have been exemplary. They have given quick and thorough updates. I really encourage you to look at their security blogs. And it turns out that SolarWinds is a .NET technology, .NET shop, and the vulnerability was in a .NET architecture. And here it is, they've made it public. So SolarWinds is written in .NET Framework, not .NET Core, .NET Framework. It's a little bit old school, but by no means an outlandish architecture. So the way it works is they have an executable, a layer host.exe that looks for plugins in the general assembly cache in the GAC. So these are strongly named signed binaries, so they're in theory they're not vulnerable. You can't just dump them in the gap yourself. And how the plugin works is there's a core business layer plugin is the entry point with a start method and a schedule background inventory method that gets called quite regularly. And that calls another class called inventory manager with a refresh internal. And it was in here that the hackers gained, we don't exactly know how they inserted the malicious code, but it seems like they maybe stole credentials and they had access to the build pipeline, because when they inserted the malicious code, it was built and signed using the appropriate certificates, which is why it could be deployed into production. And how the exploit worked is that very stealthily, it started in a new thread some code in a class called Orion Improvement Business Layer. So innocuous sounding. It would be much easier if they called it, dirty, rotten hack. And once this was executing on the target network, so on, they were very careful not to run on any SolarWinds environments. They were very careful not to run on any test environments that might detect the malicious code. And they didn't run when there were any virus scanners or Wireshark or any of those kind of tools running either. They wanted to lurk inside the networks they were targeting for a long time. We believe they're in there for about a year. So once the code was running on the target network, the first thing we would do was rename Windows admin tools, because they tend to have very lots of privileges to run on the host machines. Once that happened, we run PowerShell scripts, and we're not sure if the program stole the credentials or whether other kinds of hacks stole the credentials. There was another hack that managed to disable them two-factor or multi-factor authentication. So there was a lot of attacks on this infrastructure. And then when they were in, they would, for each machine in the target domain they were running on, they would create they would call out to a target, a new domain on the internet, which would then be used as a command and control server for black hats to execute commands on the machines themselves. And they also got access to the private certificate for creating SAML tokens. So they managed to forge SAML tokens, and with the forged tokens, they could go anywhere on the target network. They could call into software as a service products. They could call into the cloud providers. They really had the keys to the kingdom at this stage. So just they've also published the code just to show you how innocuous it was. So this is the refresh internal method that I showed you in the plugin as it starts up. So nothing but a logging, bit of queuing, fine. And the hackers inserted a little method in here. You can tell they're international hackers because they swallow their exceptions. There's nothing in the try catch block. So in my opinion, if you catch exceptions and don't log them or do anything with them, you too are an international terrorist and should be wearing an orange jumpsuit, in my opinion. But so you'll notice all it does is it calls into this Orion Improvement Business Layer initialize on a new thread. And once in there, carried out its nefarious business. And you notice they even went to efforts to obfuscate and be non-threatening code that was zipped and encrypted instructions. I think each of those is a line that says do something nasty. So there we are. This is a supply chain attack where the supplier of network software had their software compromised, and then that ran all the way through to run as trusted software on the target networks. So that's the SolarWinds attack. The other one I want to mention is this is Vastaamo, which is a chain in Finland of psychotherapy clinics. So this is mental health therapy sessions, so really very sensitive information. As it happens, my first job ever as an application developer was in a psychiatric hospital in Dublin, the St. John of God Hospital, where we were developing an electronic patient record system. And we considered mental health records to be about the most sensitive and personal information you could have. And we went to great lengths to keep the information secure. We ran the database ran on its own private network, not connected to the internet. You could only be accessed on cut-down Windows NT machines. Could run no other applications other than the thin client we wrote. So, we regarded this data as extremely sensitive. I think it's fair to say that Vastaamo didn't treat it quite as sensitively as we did, because their electronic patient record system was kept on a SQL Server database exposed to the internet. Apparently, it was available in Google search, and we don't know, but when the data was stolen by an unknown assailant who called himself Ransom Man on the Tor boards, Ransom Man claimed that he accessed the electronic patient record through a default username and password, which might even have been root. So these were conversations incredibly sensitive, of all kinds of addiction issues and personal issues that were completely unprotected. So as it happens, Ransom Man, there were 40,000 records stolen. Ransom Man turned out to be a piece of human garbage who tried to blackmail the clinics, and when they didn't pay the ransom, he created 40,000 Bitcoin addresses and blackmailed the patients individually, some of whom were children. And when people didn't pay up, he started publishing 100 at a time the mental health records of these victims. It turns out he's committed the biggest crime in the history of the state of Finland, and remains at large. But I don't think he's been able to, or he or she has been able to convert their Bitcoins into actual money yet. And they remain the most wanted criminal, I think, in Finland. It's on the similar line as, to extend that, data crimes, while there's not as many victims as this, have, the end of last year, any of you runners will remember that your Garmin watches stopped working for a bit, as Garmin had their data encrypted, and they were locked out of their own company for a week. It's believed they paid a ransom. We don't know how much. And I believe Manchester United were also a victim of ransomware. So these data exploits are extremely damaging to companies. So with that, we left to ask, what can we do as application developers to make our applications more secure? And the first thing I say, I don't really know. These are certainly, some of these attacks are, very, very sophisticated and very high level. And, I really hope I don't ever get one of these. But just, thinking of a few ideas, the first thing that occurred to me is to be aware of what's happening in your environment. I asked myself, would I know if my credentials were stolen and someone inserted some code into the code base I was working on? And I hope I would. I do keep an eye on the pipelines. I do keep an eye on the alerts, but I probably get too many notifications in my email of people who are responding to people who make comments on my PR requests, or, this has happened or that has happened. I should maybe restrict my alerts to pull requests that have completed in my name. That should be an event I'm aware of. And on that, the other thing we can do is to lean on tools. So I don't have any recommendations on particular tools to use. I haven't done a survey or anything like that. And I suspect there would be lots of vendors claiming that, buy their tool and be safe from all these. And there may well be tools, but I have no particular recommendations. The one, I have been looking at with our security ops guys is Microsoft Defender. And that's been extremely useful. Microsoft have put a lot of effort into it, I think, and So for example, if you have we looked at Microsoft Defender, and there's a very good explanation of the SolarWinds attack. It's called SolarWinds, which is the code name that Microsoft have given this attack, and there's a very good explanation of it. And Microsoft have published some queries that you can run in Microsoft Defender to detect any of the compromised binaries on your system. We ran this on the Amido network, and I was happy to say we have no compromised binaries, but I don't think we ever had any SolarWinds in the first place. So this is more an example than a relief. So, I've been very impressed with Microsoft Defender, and it is also integrated into Azure very well. So I don't know if this will work. So let's see if we can show this. This is a little database I have made and exposed to the internet on Azure. I'm making a little COVID passport database, so if anyone wants to send me their details, I can put you on the database. It is exposed to the internet, but that's the thing. So if you look in the security tab of here, it immediately Azure security will tell you that internet-facing virtual machines should be protected with network security groups, and it deals with vulnerability assessments. So do lean on the tools, especially the cloud providers. I think are going to give a very good defense against this kind of attack. For databases, you can apply policies in your cloud provider to make sure no one is doing anything as reprehensible as exposing databases to the internet, and you can also have good visibility on what your actual setup is. So that would be my, one of my recommendations is lean on your tools and investigate them. The next thing is, definitely rotate your keys regularly. If you're assigning binaries to go out into the world, the keys should be rotated regularly. These hackers, the exploits, they lived in these networks for a long time. Their idea was, they didn't want to get in and out. They wanted to stay inside the network. So do rotate the keys. And finally, what I want to talk about is the notion of zero trust, which is I think we're going to hear a lot about this paradigm as we go forward. This is the idea that all of your microservices should assume that the other microservices in your network have been compromised, and the elements of zero trust are that you should authenticate using all the information you have about a call, the device that it's coming from, and any geographical information, and so you really authenticate using all the information you have about the caller, and that you assume that your other microservices have been compromised, and they call it reducing the blast radius. So you take steps to stop a single component being an attack vector that you can spread through people's networks from a particular component. So I don't have much to say about zero trust. My instinct is that we will need to then understand the costs of locking down these networks, with the idea of zero trust before we go into it. But I just wanted to flag that up as something that I think we're all going to have to get to grips with in the next, as the future of our industry unfolds. So I'd like to thank you all for listening. Thank Dr. Roundabout for the chance to show you all this. You can contact me at my email at Amido, or shout at me through LinkedIn. So thanks. I'll hand back now to see if what questions there are. But that is thank you for listening.
Fantastic. Thanks very much. Thanks very much, Aidan. We've just got a couple of questions here in the comments section. So I'll just go from the top down. So a question for Aidan. It seems like security is an arms race. How do you stay ahead of the game?
So it's a good question. My instinct is that the cloud providers are our friends here. That if you look at the Microsoft security blog, for example, the lengths to which Microsoft, and I'm sure the other cloud providers are the same, AWS, GCP, they have a lot of resources to devote to security and to defending against attacks. So my instinct is that if you're inside, running inside a private network or software is in a managed service within a cloud provider, you have a very big advantage. If you're running on premises, that's fine. I'm not telling anyone to stop running on premises, but you will have to factor in the the amount of effort you're going to have to devote to security as part of your calculations about running on premises rather than in a cloud provider. But my instinct is to lean on the cloud providers here to help us in this game.
Brilliant. Oh, fantastic. Eugene, I've got a question for you. So ASOS do crazy numbers for Black Friday and Christmas. How are you able to scale those systems so much and so quickly?
So I think I'm going to say very similar to what Aidan has said, cloud providers. Yeah, so usually before big events or sale events, I'm not 100% sure exactly how we do it. I just know I get the notifications for other departments. So beforehand, they will scale up everything with certain anticipation. We obviously have a good idea of what volumes to expect and what sort of loads to expect. But besides scaling, I think there's also a factor of engineering. I think we've got good engineers and we're always optimizing what we're doing. And hence the reason why we're re-platforming everything is to cope with the scale.
Fantastic. Aidan, I've got one more for you here. So how common would you say security breaches are for the average company in London, for example? How
I have no
these sort of things, or people trying to sort of...
Yeah, I have no particular statistics, so I don't know for an average company particular numbers, but there are a lot of hackers out there. That's the I would say in terms of the common attacks, definitely the OWASP is your place to go. They I can't remember what OWASP stands for. It's the Open Web Application Security Initiative, something, I don't know, something like that. But they're go to their website, have a look at the trends in attacks, and defend yourself against the common attacks as defined with the OWASP top 10. That's the really place to go. And then these attacks, I have no particular statistics on them, but they just they do scare me a little bit. That's all.
Yeah, no, fine. I remember there's a big one. Was it a few years ago on the NHS? That was a ransom?
Yes, it was. Yeah, I think that was a WannaCry.
Yeah, that was the one.
A WannaCry encryption.
And wasn't that just from something as simple as it was like old Active 360 accounts?
The Windows NT network, wasn't it? That I think got exploited like that. And yeah, so one of the ransomware attacks against hospitals during the COVID epidemic is not just in the UK, but it's one of them. It's pretty shameful, but they exist as well. So it's there's some grim stuff out there.
Yeah, really, really relevant. Eugene, I've got one more for you. What is the most common sort of technical challenges that you're coming across day to day in your role?
Most technical challenges. I think it's just probably availability of systems. Although we do well, I think there's always problems and technical challenges, and I think it's also being very fast-paced. Things is constantly always changing. So it's maybe not a technical problem, but I think it definitely keeps it interesting.
That's fantastic. Aidan, Eugene, thank you very much. And obviously, Beth is in the background. You can't see her, but thank you, Beth, for doing all the organising. Thanks everyone for watching. We'll have this link shared throughout sort of the group, and Aidan and Eugene will send this link over to you as well if you want to share it through your networks.
Cheers. Thank you very much for your time.
Thank you very much. That was fun.
Thanks very much.
Cheers, guys.